In lesson 3, we are determining irregular shapes. In the previous lesson, we found the perimeter and area of what we call our standard shapes: rectangles, squares, triangles, and circles. If I were to look at some of the assignment questions, we found the perimeter of a rectangle, the distance around the rectangle, and we said that there's a formula to find the perimeter: 2 times the length, the opposite sides are equal, plus 2 times the width. Then the area now is length times the width. For circle, the distance around the circle is called the circumference. So that is the perimeter. And from our formula sheet, we discovered, well, we were given that the circumference of a circle, C, is equal to 2 times pi, that wonderful number 3.14159, an irrational number, it goes on forever, times the radius. And the radius, we recall, is from the center of the circle to its circumference, which is half of its diameter. The diameter is the distance from the circumference through the center to the other side of the circumference. So the distance of from one of the circumference to the other through the center is referred to as the diameter. The diameter is 2 times the length of the radius. And then we looked at finding the area of a triangle, and from our formula sheet, we said that the area of a triangle is the base times the height divided by 2, or half of the base times height. We also found the area of a circle, which is pi, wonderful irrational number, times the radius to the power of 2. In other words, radius times radius. Now today, we will be given what we refer to as irregular shapes. So there's not a defined rectangle or a circle by itself. They are embedded within different shapes. So let's look at, and more or less they call composite shape. It's like you have different standard shapes: rectangles, squares, triangles, circles, and they're connected, they're intertwined. A good example would be one of the assignment questions we look later on, a couple of them. This one here, we have a triangle, or here we have a semicircle, and in here we have a rectangle. So within this one question, we'll have to find the area of circle, what's half of the circle, a square or a rectangle, in this case, and then we have a triangle. So this is what we call composite function, composite shape, because it's composed of different shapes: a circle, square, or a rectangle, and or triangles. Or sometimes cone. We'll find that later on when we do 3D objects. Let's look at this one. Here we asked to find the area. Now, we'll be constantly referring to our formula sheet. Now, the area of a rectangle is length times the width. But here we're not given a defined shape, we're given a composite shape. To find the area of this irregular shape, or the composite shape, we need to make it in sections. As of itself, we cannot find the area. Now, there are a number of approaches. One of the approaches I'll show you today is to make it into sections. And you can do it for a number of ways in this case. So what you want to do is to look at this shape and say, okay, how can I make this into sections? But I'm making it into section, I will then create any one of these four shapes. Because within this irregular shape are squares or rectangle, or it could be triangular or circles. It depends. In this case, there's no circle we can define here, no triangle, more likely squares or rectangle. Now, if I look at the sides here, this is 10, this is 8, so this will be a rectangle. Seems this here is 15. Now, when we have a line across there, it means these two sides are equal. So once I know one measurement here, I know the other. That's what that means. They're equal. Now, since we know this will be rectangles composed because there's no circles or triangles here, we can safely write down the formula for a circle, for a rectangle. Oh, rectangle, which is the length times the width. The next step, we are going to make this composite shape into sections, and I'll make it into two sections. I'll call this area 1, the area 2. So now you can label it however you want. Next, I am going to determine the measurement for each of these sides that doesn't have any measurement. Now, since a section of this part here, and this is perpendicular, it means the opposite sides are equal. Now, this is a rectangle, and in a rectangle, if we have the sides are perpendicular in the rectangle, then the opposite sides are equal. So this will give me 15 centimeters. Opposite sides are equal here. This becomes 8 centimeters. It's already there. Now, what is the measurement of this part here? Notice, this is 10. Now, if also this is 10, this is the opposite side. So if now this side is opposite this side over here, so these two sides must be equal. Now, if this is 10 and these two measurements are equal, well, 10 divided by 2, this will be 5. And this here will be 5. So therefore, side is 5. So area 1, length times width, is 15 multiplied by 5. So let's work it out here. So area 1, length times width is equal to 15 centimeters multiplied by 5 centimeters. Let's get on my good calculator here. $15 times 5 gives me 75 square centimeters. So area 1. Area 2, length times width, we have 10. The length here would be, if you make this the length, 10 multiplied by 8 centimeters, it gives me 80 centimeters square. Total area is area 1 plus area 2. Now, area 1 is 75 square centimeters, and area 2 is 80 square centimeters. So the total area, I'll calculate here, 75 plus 80 gives me 155 square centimeters. So total area. So quickly review. First of all, we recognize these are rectangles. When we after we section off this composite shape, and then we find the area for each after determining the missing measurements. We're asked example 2, find the area of this shaded part of this shape here. Now here we have to find the area of the rectangle, find the area of the circle, and subtract it. Just imagine you have a rectangle. I'm going to show you right here. This is a rectangle. We find the area of the rectangle, which is the length times the width. But then if I were to put a circle in here, say and I just want to find this area here, I already know the area of the entire rectangle. What I'll do now is to find the area of the circle. If I just want to find this section out, I don't want to find the whole part. I want to minus the circle. So it will be area of the rectangle minus the area of the circle, which will give me the area of the shaded part. Now, this shape, we're given the length, but we're not given the width. But here's something interesting. If the circles fit, if these two circles fit into this rectangle, it means the diameter of both of these rectangles are the same because they're identical circle. This here would be the diameter. And so these two sides are equal. So if these two sides are equal, its diameter are also equal. Yeah. So since this is the diameter and they are equal, so we have a diameter here. Since the diameters are equal, we can conclude that the diameter is 10 meters because the entire length of within two circles that are touching each other is 20. So therefore, this would be 10 centimeters. 10 centimeters equal 20. And therefore, this also would be 10 centimeters. So we can conclude this is 10 centimeters. So be careful, because once we know this measurement here is as a diameter, then the diameter is same regardless of what position, what angle you measure your diameter. To find the area now of the shaded part, it will be the area of the rectangle minus the area of the two circles. We can find that here. We said that the area of shaded part is equal to area of rectangle minus areas of two circles. So let's find the area of the rectangle. Let's put that up here. Area of rectangle is equal to the length times width, which is equal to 20 meters multiplied by 10. Oops, it should be meters here, not centimeters. Can't have two different measurements. Oops. It's 20 times here. My good old calculator here, make sure I'm on the accurate path. So 20 multiplied by 10 gives me 200. So 200 square meters. So we have a rectangle. So we can see if we put that here, it's 200 square meters minus now area of two. Let's find area of one circle and then we multiply by two. So two circles is equal to 2 multiplied by the area of one circle, which is, okay, this is a little bit more orderly. Area of one circle is equal to pi r squared. And that's, you have to refer back to your formula sheet, area of a circle, pi r squared. Now, the radius here would be half of the diameter. The diameter is 10, and therefore the radius is 5. So radius, put that in the corner here, because it's half of, so we get that pi times 5 squared, which is 70.54. Okay, let's double check that in my calculator here. We have second pi times 5 squared. 78.5398. I rounded up to do the 2 decimal places. So 2 multiplied by 78.54 square meters. The line here to separate the two, which is 200 square minus, now multiply that by 2, 157.08. Then we subtract, so minus 200, gives me 42.92. So area of shaded is equal to 42.92 square meters. Example 3. This composite shape looks like a section of a circle. You see, if I were to continue this here, this is a circle, but a section is removed, and you're asked to find the area of it. Now, there are a number of ways of doing this, but the easiest way is to find the area of the circle and then find the area of the shaded section here, which is 1/4. It's one, and subtract it. Or we know this is 1/4, and then that's not shaded. So therefore, 3/4 is shaded. So the area of the shaded part would be 3/4 of the circle. So this area here now is 3/4 of the circle. So to find the shaded part, you find the area of the circle and 0.75 or 3/4 of it. So we said right away we know this is a circle, and the area of the circle is pi radius squared. The radius here is 5 centimeters because it's giving you from the center to the circumference. Radius equal 5 inches. So area of this figure, so area of figure is equal to 3/4 or 0.75 times the area of a circle. Which is, now if you don't like fractions, you can always switch it over to decimal, which is 0.75. 3 divided by 4 will give you this, times pi r squared, which is 0.75 multiplied by pi multiplied by your radius, which is 5 inches, to the power of 2. So get on my good old calculator here to do some work. Now, you may want to work backwards. You may want to go 5 to the power of 2. So I'll do this a little more step by step, times pi 5 to the power of 2 pi squared equals 25. Now I can multiply them. Straight circuit times. Now I'll go from left to right. 0.75 multiplied by pi. Use your pi button in your calculator. Do not skip it and put 3.14. You get an approximation, pretty close, but not as accurate as required. multiply by 25, which is 58.9 inches. So the shaded area is 58.9 inches, or area of figure. Now, in this figure, it's composed of different, we call it regular shapes. You're asked to find the shaded area, but let's ignore the shaded area. Let's imagine we don't have anything shaded. So probably going to look, if I were to do a sketch here, look like so that we have it. This looked like a semicircle or half of a circle. Now ignore this line here. This looks like a rectangle, and I'll just border it up. You see right away this is going to be a rectangle here. Put it over here. And now if we look at this part here, this is a triangle. And what are we given? We're given, this is 7 miles, 4 miles. And if we were to just find the area for each section, this is a circle. Now, the question is, to find the area of a circle, we need the radius. This is 4, therefore this would be 4 here. So now we have the measurement. The other part now, it tells us that these two sides are equal. So this is 4, therefore this would be 2, and this would be 2. And therefore would be 7. So first thing we do, we find the area of this rectangle, find the area of the circle, and that will give us the area for the whole section. So basically we're trying to find the area for the whole thing first. Then listen, now I want to minus this part here. I don't want this part because I simply now want to find this section here without. So I do not want to find this area here. This area now becomes out of the factor. Now I'm just going to find the rest of it. So steps are, number 1, find the area of the semicircle, the rectangle, and then find the area of the triangle and subtract it from there. So this entire area that's shaded is equal to the entire composite shape minus the area of the triangle that's within the shape. Okay, let's move this out here. So step 1, let's try to put some numbers to the missing sides. We know this is equal, this is just lines mean, so this would be 2, and this would be 2 miles also. This would be 7 miles. This diameter here would be 4 miles, so therefore the radius is 2. we can conclude that the shaded area, that's what we want to find, shaded area, is equal to the, the area of the rectangle plus the area of the semicircle, which is half of a circle, minus the area of the rectangle. So we can say area of rectangle plus semicircle minus area of a triangle. First step, let's find the area of the top part, area of semicircle. Remember, semicircle means half of a circle. So half which is half of the area of a circle. Which is pi times half times pi times radius squared. Which turns out to be half multiplied by pi, and the radius here is equal to 2, so radius 2 miles. We can change this to 0.5. 1 divided by 2 is 0.5 to make it into decimal. 2 to the power of 2 is 4. And we simplify this to be 6.28 square miles. Let's verify that. Point 0.5 multiplied by pi multiplied by 4, 6.28. So we can replace that here with 6 point. Sorry, plus over here. I'll find the area of the rectangle. Now I'll remove this from here. So area of something times width. So give me 7 multiplied by 4. 28 square miles. Now, area of triangle. Base times height divided by 2. We got a base is 2. And the height is 7. So 14 divided by 2. give us 7 miles. Seven square miles. So let's work this out. We have 28 plus 6.28 plus 6.28 gives 34.28 square miles minus 7 square miles, which worked out to be minus 7 square miles $27.28 square miles. Shaded area. So we conclude the shaded area. 27.28 square miles. So let's review. We set out today to find the area of irregular shapes. And we say irregular shapes are figures that have the standard shape, do not have the standard shape. In other words, they don't define rectangle, square, circle, or triangles. Therefore, when we ask to find the area, we have to find sections of the composite objects. In the first example, we have a section of this composite shape to create 2 rectangles and find the area of the rectangles. The second one, we ask to find the shaded area, so we find the area of the rectangle and find the area of the 2 circles and subtract it. So we are more or less subtracting one from the other. The next one, we have a section of a circle, which is 3/4 of a circle. And therefore, we find the area of the circle and find 3/4 of it. The alternative to this question, you can find the area of the circle, then find 1/4 of the circle and subtract it. You'll have the same result. In other words, find the area of the circle, find the area of 1/4 of a circle, and subtract it. A little bit more work, but it's also another way of completing the question. And for this part here, we have, well, there's 3 sections or 3 different kinds of regular shape. Circle or a semicircle, we have rectangle and a triangle. We find the area of the 2 semicircle or half of a circle and a rectangle. We add them, and then we find the area of the triangle, and we subtract to the area from it, the area of the triangle from the total area of the semicircle and rectangle to give us the shaded part. You can go on to assignment 3, and you have 3 questions. The first one, just remember, this means equal dimension. So this is 12. This would be 6 and 6. They're equal. And he has to find the figure. The next one is a little bit trickier because it doesn't. One of the things you have to remember, these questions, when their diagrams are given, they're not drawn to scale. So they don't look exactly what the dimension tells you. So remember that you're not drawn to scale. But here is the thing here. This is a half of a circle, a semicircle. The diameter is 80. Now, it doesn't look, but also therefore this from here to here will be half. So this is 80. So therefore the radius is 40. So you'll need to find the area of these two semicircles and find the area of the rectangle. Now, we now know the area of the rectangle, which is 200, and the width is 80. So we know this is going to be 80 in here. The third question, you have to section off, and that gives a triangle. Here you have a circle. The radius here would be 15. So because we need to find the area, so this would be 15 and 15. This base here would be 30. Now this would be 30. Now the height here, because remember the triangle is base multiplied by height divided by 2, or half of the height now. Since we know the radius is 15, from here to here is 15, so this is 15. The height here, since the whole entire length from the tip here of this semicircle to the end of this triangle, so we have triangle here, is 70. Therefore, what's left over here, it will be 30. So we have here 30, 15. So it'd be 70 minus 30 minus 15. So I'll leave that for you to calculate, since I'm giving you these two here.